June 12, 1944. Sainte-Mère-Église, Normandy, France. The morning broke gray and heavy over the hedgerows, the air thick with moisture that clung to everything: uniforms, equipment, the leaves of the ancient Norman bocage. Hauptmann Ernst Becker crouched in the commander's cupola of his Panzer IV, scanning the sky through field glasses that kept fogging in the humid dawn. His tank was positioned beneath a dense canopy of oak trees, camouflaged with cut branches and netting, invisible from above, or so he believed. 6 days had passed since the Allied invasion, 6 days of chaos and confusion, of orders that contradicted previous orders, of promised reinforcements that never arrived. His unit, the remnants of the 12th SS Panzer Division, had been trying to reach the invasion beaches, to drive the Americans back into the sea as doctrine demanded. But the skies belonged to the enemy now. Every road was watched. Every movement drew fire. Becker heard it before he saw it, a sound like distant thunder growing rapidly closer, a deep rumbling roar that seemed to shake the very air. He turned his glasses skyward, searching the low clouds, and then it emerged. A massive aircraft, painted in olive drab with white invasion stripes, flying low and fast, so low he could see the oil streaks on its cowling. It was an American fighter, one of the new types that had appeared over France in recent months. Enormous, brutal, flying with a kind of aggressive confidence that suggested its pilot feared nothing on the ground or in the air. The aircraft banked sharply, rolled to line up with the road, and Becker realized with cold certainty that it had spotted something. Spotted them, the Thunderbolt dove. The sound intensified, the engine note rising to a scream as the fighter plummeted toward the hedgerows. Becker shouted a warning, unnecessary. His crew had already heard, were already scrambling, the driver gunning the engine, trying to move, to get the tank out from under the trees. But they were too slow. Everything was too slow. The American fighter howled overhead at a height that seemed impossible, perhaps 50 meters, perhaps less, and from beneath its wings came a different sound entirely. A mechanical roar, a ripping, tearing noise like heavy canvas being shredded, impossibly loud, impossibly fast. 8 streaks of light converged on the road ahead, where another panzer from his unit was attempting to cross an open stretch. The tank seemed to shudder, then erupt in sparks and smoke as hundreds of rounds struck it in the span of 2 seconds. The turret hatches blew open. Smoke poured from every seam. The Thunderbolt pulled up sharply, its massive propeller clawing at the air, climbed with a power that defied its size, rolled inverted, and dove again on a second target. More fire, more that terrible ripping sound. Another vehicle destroyed, this time a half-track which simply disintegrated under the onslaught. Then the fighter was gone, climbing into the clouds, vanishing as quickly as it had appeared, leaving behind only wreckage and the acrid smell of burning fuel and cordite. Becker lowered his field glasses. His hands were shaking. In 15 seconds, perhaps 20, the American pilot had destroyed 2 vehicles and disappeared before any of them could even attempt to return fire. This was not combat as he understood it. This was execution, and the aircraft, the sheer size and power of it, the speed, the firepower, represented something his training had not prepared him for. The Luftwaffe had promised air superiority. The Luftwaffe had promised that German fighters would protect ground forces from enemy aircraft. But the Luftwaffe was nowhere to be seen, and the Americans ruled the sky with machines that seemed purpose-built for the systematic destruction of everything that moved on the ground below. What Becker could not have known, crouched in his camouflaged panzer beneath the Norman trees, was that the aircraft that had just attacked his unit represented one of the most remarkable engineering transformations in aviation history, a fighter that had been designed for high-altitude bomber escort and had been reborn, through American ingenuity and relentless testing, as perhaps the most devastating ground attack aircraft of the war. The Republic P-47, Thunderbolt, in the hands of skilled pilots and armed with weapons that German tank crews had never faced before, was rewriting the rules of tactical air support. And the Germans, despite their own excellence in engineering and their experience in combined arms warfare, had never anticipated what American engineers would achieve with this machine. The story of the P-47's transformation began not in France, but in the United States, in factories and research facilities where engineers wrestled with problems that had no easy solutions. The Thunderbolt had entered service in 1942 as a high-altitude interceptor and bomber escort. Designed around the most powerful radial engine available, the Pratt & Whitney R2800 Double Wasp, an 18-cylinder monster that produced over 2,000 horsepower. The aircraft was massive by fighter standards, over 10,000 pounds empty, nearly 18,000 pounds loaded, and was nicknamed the Jug by its pilots, partly for its bulky appearance, partly for its resemblance to a milk jug. Early combat reports from Europe were mixed. The P-47 could not turn with lighter German fighters. It was slower in acceleration. At low altitudes, it was positively sluggish. But it had advantages. It could dive like a stone, it was rugged, and it could absorb enormous amounts of battle damage and continue flying. American engineers recognized what they had. Not an elegant dogfighter, but a weapon with untapped potential. The P-47's size, its structural strength, its powerful engine, these were not liabilities but opportunities. If the aircraft could carry heavy weapons, if it could be adapted for ground attack, if pilots could be trained to exploit its strengths rather than lamenting its weaknesses, the Thunderbolt might become something unprecedented. The transformation began with weapons. The P-47 was already armed with 8 Browning M2 50 caliber machine guns, 4 in each wing, a formidable battery for air-to-air combat. But for ground attack, something more was needed. Republic Aviation and Army Air Forces engineers began testing external ordnance configurations: bombs, rockets, drop tanks. The aircraft's wing structure, massively strong to withstand high-speed dives, could accommodate hard points for external stores. Initial tests mounted a single 500-pound bomb under the fuselage centerline, then 2 bombs, 1 under each wing, then additional racks. By 1944, the P-47 could carry up to 2,500 pounds of bombs, rockets, napalm, or drop tanks, a payload equal to many medium bombers. But the real breakthrough came with a weapon that would become synonymous with the Thunderbolt's ground attack role: the 5-inch high-velocity aircraft rocket, or HVAR. Each rocket carried a 50-pound warhead and was launched from a zero-length rail mounted beneath the wing. The HVAR could penetrate light armor, destroy vehicles, blast fortifications. Testing proved that a salvo of rockets delivered from a diving Thunderbolt was devastatingly accurate at ranges where traditional bombs would miss. And the P-47 could carry 10 of them, 5 under each wing, transforming the fighter into a flying artillery platform. Equally important was ammunition. The standard 50 caliber ball and tracer rounds used for air-to-air combat were supplemented with armor-piercing incendiary rounds specifically designed for ground targets. These rounds could penetrate vehicle armor, puncture engine blocks, ignite fuel tanks. Loaded in belts that mixed AP rounds with tracers, the 8 machine guns of the P-47 delivered a concentrated stream of fire that could saw through trucks, half-tracks, even light tanks. At a cyclic rate of approximately 800 rounds per minute per gun, all 8 guns firing simultaneously produced a rate of fire exceeding 6,000 rounds per minute. A 2-second burst released over 200 rounds. The effect on ground targets was catastrophic. Wind tunnel tests and combat trials determined optimal dive angles, airspeeds, release altitudes. Pilots were trained in new tactics: the diving attack, rolling in from altitude, diving at angles between 45 and 60 degrees, acquiring the target, releasing ordnance or firing guns, pulling out at low level, using speed and surprise to minimize exposure to ground fire. The P-47's rugged construction and powerful engine made it ideal for these attacks. The aircraft could survive hits that would down lighter fighters. Its air-cooled radial engine, unlike the liquid-cooled inline engines of German fighters, could sustain damage without immediately losing power. Hydraulic lines were redundant. Flight controls were robust. Pilots discovered that the Thunderbolt could limp home on one wing, with half its tail shot away, with cylinders blown off the engine. It earned a reputation for bringing pilots home when any other aircraft would have been lost. By the spring of 1944, as Allied forces prepared for the invasion of Normandy, the P-47 had been thoroughly transformed. Fighter groups that once flew high-altitude escort missions were retrained for ground attack. Ordnance crews became experts at loading rockets and bombs in configurations tailored to specific missions. Intelligence sections analyzed reconnaissance photos to identify targets: tank columns, supply depots, rail yards, bridges, anything that supported German ground forces. The Thunderbolt, once derided as too heavy and too slow for air combat, had found its calling. It was about to become the nightmare of every German soldier in France. The Germans, meanwhile, remained largely unaware of this transformation. Luftwaffe intelligence reports from 1943 described the P-47 as a high-altitude escort fighter, dangerous in a dive but vulnerable at low speeds, best avoided in turning combat, but not a primary threat to ground forces. German ground commanders knew about Allied air superiority in general terms, knew that the Allies had many aircraft, that attacks were frequent, that movement in daylight was hazardous. But the specific capabilities of the P-47, its payload capacity, its firepower, its adaptation to the ground attack role, were not fully appreciated. German tactical doctrine still assumed that ground forces could maneuver if they were careful, could avoid detection, could reach their objectives, if they moved at dawn or dusk, when air attacks were less likely. These assumptions died in the hedgerows of Normandy. The Allied air campaign in support of the Normandy invasion was unlike anything previously attempted. Thousands of aircraft were committed to the battle, bombers striking strategic targets, medium bombers hitting tactical objectives, and fighters, especially P-47s, flying armed reconnaissance and close air support missions. The Thunderbolts operated from hastily constructed airstrips in England, flying multiple sorties per day, ranging across France searching for targets of opportunity. German commanders soon discovered that movement of any kind drew immediate attention. Tanks, trucks, even individual vehicles were hunted relentlessly. The sound of aero engines became a constant presence over the battlefield, a background menace that dominated tactical planning. For German tank crews, the P-47 represented a unique terror. Tanks had been designed to fight other tanks, to engage enemy armor and infantry, to advance under artillery fire and machine gun fire and anti-tank fire. But tanks were not designed to fight aircraft, and the tactics that worked against ground threats were useless against an enemy attacking from above at 400 miles per hour. Camouflage that concealed a tank from ground observers was often ineffective from the air. Movement that was tactically sound on the horizontal plane made tanks conspicuous targets when viewed from above. And the weapons that Thunderbolts employed, especially the 5-inch rockets, were unlike anything German tank crews had previously encountered. A rocket attack was terrifyingly sudden. The P-47 would appear, often diving out of the sun where pilots could not be seen until the last moment. The aircraft would roll into its dive, line up on the target and release a salvo of rockets from a distance of perhaps 1,000 meters. The rockets would streak downward, visible as smoke trails, moving faster than the sound of their launch, giving crews perhaps 2 seconds to react. Impact was devastating. Even a near miss could disable a tank. The blast concussion shattering track links, jamming turrets, killing exposed crew. A direct hit could penetrate armor, the 50-pound warhead detonating inside the vehicle, killing everyone instantly. The 850 caliber machine guns were equally deadly against softer targets. Supply trucks, fuel bowsers, ammunition carriers, half-tracks, all were vulnerable to concentrated machine gun fire. A single strafing pass could destroy an entire convoy. Pilots learned to target the lead and rear vehicles first, trapping the column, then working through the middle vehicles methodically. Fuel trucks exploded. Ammunition trucks detonated with secondary explosions that destroyed nearby vehicles. Troops caught in the open were cut down. The armor-piercing incendiary rounds punched through vehicle bodies, through engine blocks, through anything less than heavy armor plate, leaving burning wrecks in their wake. German after-action reports from Normandy are filled with references to air attacks, to losses from enemy aircraft, to the impossibility of movement in daylight. One report from the Panzer Lehr Division, which attempted to reach the invasion beaches in the days following D-Day, described continuous air attacks that reduced the division's combat strength by 40% before it even engaged Allied ground forces. Tanks were destroyed, supply vehicles burned, the division was scattered and disorganized. Another report, from a regimental commander whose unit was caught on the road by Thunderbolts, stated simply that his regiment had ceased to exist as a fighting force. 70% casualties from a single air attack. The psychological impact was as significant as the physical destruction. German soldiers, even experienced veterans from the Eastern Front, had never experienced air power employed with this intensity and precision. On the Eastern Front, Air attacks were frequent but often uncoordinated. Pilots operating with limited communication with ground forces, striking targets of opportunity without systematic planning. In Normandy, Allied air power was integrated into the battle plan at every level. Forward air controllers directed attacks on specific targets. Reconnaissance aircraft identified German positions and movements. Fighter bombers responded within minutes to requests for support. The entire system was designed to locate, track, and destroy German forces with industrial efficiency. The P-47 was the primary instrument of this system. Its range allowed it to operate across the entire Normandy battlefield. Its payload allowed it to attack any target from tanks to trains. Its ruggedness allowed it to survive the intense ground fire that German forces threw up in desperate attempts to defend themselves. And its numbers, hundreds of Thunderbolts operating over France simultaneously, made escape impossible. A German column might evade one attack, might survive one dive-bombing run, but the fighters would return again and again until the column was destroyed. Pilots who flew the P-47 in Normandy described their missions with a mixture of professional satisfaction and grim awareness of what they were doing. These were not distant strategic targets, not factories or rail yards seen from 20,000 feet. These were men and vehicles visible in detail, faces sometimes visible in the final seconds before impact. Some pilots struggled with this aspect of ground attack, the personal nature of the killing. Others rationalized it as necessary, as shortening the war, as saving Allied lives by destroying enemy forces before they could engage friendly troops. All acknowledged that it was effective. The Thunderbolt in the ground attack role was perhaps the most lethal aircraft in the Allied arsenal. Technical improvements continued throughout 1944. The P-47D model, which bore the brunt of the Normandy fighting, was supplemented by newer variants with enhanced performance, uprated engines, improved superchargers, better cockpit visibility, increased fuel capacity. The P-47M, developed late in the war, could reach speeds approaching 470 miles per hour in level flight, making it one of the fastest piston-engine fighters ever built. At these speeds in a dive, the Thunderbolt was essentially uncatchable by German fighters or anti-aircraft fire. It would appear, attack, and be gone before defenders could react. But speed was only part of the equation. What made the P-47 devastating in the ground attack role was the combination of attributes: speed, firepower, payload, ruggedness, range, and the training and skill of the pilots who flew it. American pilots received extensive training, hundreds of hours before they entered combat, practicing dive bombing, rocket attacks, navigation, formation flying, emergency procedures. They flew aircraft that were maintained to high standards by skilled ground crews who had access to spare parts, tools, technical manuals, everything needed to keep the machines operational. The entire system, training, maintenance, logistics, tactics, was designed to maximize the effectiveness of the weapon. This systematic approach was characteristically American, reflecting an engineering and organizational mindset that prioritized measurable outcomes and continuous improvement. When a tactic failed, it was analyzed and modified. When a weapon proved ineffective, it was replaced or improved. When pilots reported problems, engineers investigated and implemented solutions. The P-47's evolution from escort fighter to ground attack specialist was the result of this process. Identify a need, develop a solution, test it, refine it, deploy it, assess results, repeat. The Germans had a different approach to military innovation, one that often produced brilliant individual solutions, but struggled with systematic implementation. German engineering excellence was undeniable. Their tanks, their jets, their rockets represented cutting-edge technology. But German production capacity could not match American output, and German logistics struggled to supply forces in the field with the equipment and spare parts they needed. A Tiger tank was superior to any American tank in direct combat. But if it broke down and spare parts were unavailable, it was useless. A Me-262 jet fighter was faster than any Allied aircraft, but if fuel was scarce and trained pilots were depleted, it could not contest air superiority. The P-47 represented a different philosophy, not the best possible fighter, but a good enough fighter produced in sufficient quantities and employed with effective tactics. Over 15,000 Thunderbolts were manufactured during the war, more than any other American fighter except the P-51 Mustang. This production depth meant that losses could be replaced, that new units could be equipped, that improvements could be incorporated into later production runs without disrupting supply. It also meant that the aircraft became familiar to everyone who flew it or maintained it. That expertise accumulated, that the entire organization, from factory workers to frontline pilots, understood the machine intimately. This familiarity bred confidence. Thunderbolt pilots trusted their aircraft. They knew it could absorb damage. They knew it could carry them home. They knew that if they flew it within its capabilities, if they used proper tactics, they would survive and succeed. This confidence translated into aggressive tactics, into willingness to press attacks, into effectiveness in combat. German soldiers on the receiving end of these attacks faced pilots who were skilled, confident, and flying machines that seemed nearly indestructible. The symbolism of the P-47 extended beyond its tactical role. To Allied forces, the Thunderbolt represented American industrial power and technological capability. Here was an aircraft that weighed as much as some bombers, that carried more ordnance than most attack aircraft, that could outrun, outclimb, and outdive anything the enemy possessed. It was big, loud, powerful, characteristics that Americans embraced rather than apologized for. The aircraft's very existence was a statement. American engineering did not need to be elegant or efficient. It could be overwhelming. It could solve problems through application of power and resources, through brute force guided by competent design. To the Germans, the P-47 became a symbol of a different kind, evidence of American material abundance, of the industrial capacity that produced thousands of aircraft, while Germany struggled to replace hundreds. Every Thunderbolt over Normandy represented factories in America that were beyond the reach of German bombers, workers who were safe from attack, resources that were essentially unlimited. The aircraft was not just a weapon. It was a reminder that Germany was fighting an enemy with deeper reserves, greater production, longer supply lines that could not be cut. German military theorists had long understood that modern war was industrial war, that victory depended on manufacturing capacity as much as battlefield prowess. But understanding this in theory was different from experiencing it in practice, from watching the skies fill with enemy aircraft day after day, from seeing supply columns destroyed faster than they could be replaced, from realizing that the enemy could afford to lose aircraft and pilots and simply produce more while German losses were irreplaceable. By the autumn of 1944, as Allied forces pursued retreating German armies across France, the P-47 had fully matured in its ground attack role. Tactics had been refined through hard-won experience. Pilots knew how to identify targets from altitude, how to set up attacks, how to avoid ground fire, how to coordinate with forward air controllers. The aircraft itself had been optimized. Rocket racks were improved, bomb release mechanisms were refined, armor plating was added to protect pilots from ground fire, radios were upgraded for better communication. The results were measurable. Allied intelligence estimated that fighter bombers, primarily P-47s, accounted for a significant percentage of German vehicle losses in the European theater. Exact numbers are difficult to establish. Overclaiming was common. Multiple pilots sometimes attacked the same target. Ground forces also destroyed vehicles. But the general impact was undeniable. German mobility was crippled. Reinforcements could not reach the front. Supply lines were interdicted. The systematic destruction of transportation, infrastructure, and military vehicles contributed directly to the collapse of German defensive positions and the success of Allied offensives. Individual accounts from German soldiers who survived the war consistently mention the terror of Allied air attacks. Interviews conducted by historians decades later reveal psychological scars, memories of helplessness, of watching comrades die, of waiting in ditches and under trees while Thunderbolts circled overhead hunting. Some veterans stated that they feared Allied aircraft more than they feared Allied tanks or artillery. Artillery could be evaded by taking cover. Tanks could be fought with anti-tank weapons. But against aircraft diving at 400 miles per hour, there was no effective defense. You could only hide and hope. American pilots who flew P-47s in the ground attack role had their own perspectives on the experience. Some described it as the most dangerous flying of the war. Low-altitude attacks exposed them to small arms fire, machine guns, light anti-aircraft guns, even tank main guns firing at aircraft. Losses were significant. A single bullet through the engine, a lucky burst from a German soldier with a rifle, could bring down a Thunderbolt. Many pilots were shot down and killed. Others were shot down and captured, spending months or years as prisoners of war. Still others completed their tours, flew their 50 or 70 missions, and went home, carrying with them the knowledge of what they had done, the vehicles they had destroyed, the men they had killed. Post-war analysis confirmed what combat experience had suggested. The P-47 Thunderbolt was the most effective ground attack fighter-bomber employed by the Allies in Europe. Its combination of firepower, payload capacity, durability, and performance made it ideally suited for the role. Other aircraft served admirably: P-51 Mustangs, Hawker Typhoons, P-38 Lightnings. But none matched the Thunderbolt's overall effectiveness in the ground attack mission. The aircraft that had begun the war as a high-altitude escort fighter had ended it as a tank killer, a truck destroyer, a systematic instrument of tactical air power. The transformation had not been accidental or inevitable. It was the result of deliberate engineering, systematic testing, tactical innovation, and organizational learning. American engineers had recognized the potential in the P-47's robust airframe and powerful engine. They had developed weapons and tactics to exploit that potential. They had trained pilots to use the aircraft effectively. They had produced enough Thunderbolts to sustain operations despite losses, and they had integrated the aircraft into a larger system of air power that included reconnaissance, coordination with ground forces, logistics, and continuous refinement based on combat results. The Germans never fully understood this transformation until they experienced its effects on the battlefield. Intelligence reports had noted the P-47's presence, had documented its capabilities in air-to-air combat, had warned that it was a capable high-altitude fighter. But the shift to ground attack, the massive increase in ordnance carrying capacity, the development of tactics specifically designed for destroying ground targets, these developments were not fully appreciated until German forces in France found themselves under relentless attack from aircraft they could not evade and could not effectively defend. Against the failure to anticipate, the P-47's ground attack role was not due to intelligence failure or lack of imagination. It reflected a broader difficulty in assessing an enemy whose approach to warfare was fundamentally different. German military tradition emphasized tactical excellence, technological sophistication, and decisive maneuver. American military practice emphasized systematic planning, industrial production, and overwhelming material superiority. Both approaches had strengths and weaknesses, but in the context of World War II, in a conflict that became a test of industrial capacity and sustained logistical effort, the American approach proved more effective. The P-47 Thunderbolt, in its evolution from escort fighter to ground attack specialist, embodied this American approach. It was not the most elegant aircraft. It was not the fastest or the most maneuverable or the longest ranged. But it was effective. It did the job it was designed to do, and it did it with a reliability and consistency that made it one of the most important weapons of the war. Hauptmann Ernst Becker survived the war, though his Panzer did not. His unit was destroyed piecemeal over the summer of 1944, ground down by attrition, by air attacks, by overwhelming Allied material superiority. He was wounded in July, evacuated to a hospital in Germany, and by the time he recovered, the war had moved on without him. After the war, he worked as a teacher, lived quietly, spoke rarely of his experiences. But in interviews conducted in the 1980s, when historians sought to document the German perspective on the Normandy campaign, he spoke of the Allied air attacks, of the P-47s that had hunted his unit across France. He described the sound of the Thunderbolt's engine, the Pratt & Whitney radial roaring at full power, a sound that carried across kilometers that announced the aircraft's approach, that gave perhaps 30 seconds of warning before the attack began. He described the sight of rockets streaming down, the smoke trails converging on targets, the explosions that followed. He described the helplessness, the knowledge that tanks designed to fight other tanks were defenseless against aircraft, that armor that could deflect anti-tank rounds offered no protection against rockets or bombs, that the only defense was concealment, and that even concealment often failed. When asked if he had expected such attacks, if his training had prepared him for the intensity of Allied air power, He paused before answering. His training, he said, had been excellent. He had learned tactics, gunnery, maintenance, leadership. He had learned to fight British tanks and American tanks, to engage enemy infantry, to coordinate with supporting units. But nothing in his training had prepared him for what he experienced in Normandy. The scale of the air attacks, the persistence, the systematic nature of the hunting, this was beyond what he or his fellow officers had imagined. They had known intellectually that the Allies had air superiority, but knowing it and experiencing it were different things. He spoke of the American aircraft with a kind of grudging respect. The P-47, he said, was the aircraft they feared most. It was big and ugly and brutal, and it carried weapons that could destroy anything on the ground. When you heard that engine sound, you knew you had perhaps seconds to find cover or to die. Most often you died. The aircraft was everywhere, circling overhead, diving out of nowhere, attacking anything that moved. It was like fighting an enemy who could see everything and strike from any direction with impunity. This was the reality that German engineers and commanders had not anticipated. That American engineers would take a large, heavy fighter and transform it into a precision ground attack weapon. That they would develop tactics and weapons to maximize its effectiveness. That they would produce it in such quantities that the skies over Europe would fill with Thunderbolts, hunting German forces relentlessly. The transformation of the P-47 was a testament to American engineering flexibility, to the willingness to adapt designs to meet operational needs, to prioritize effectiveness over doctrinal purity. In the broader narrative of World War II, the P-47's ground attack role represents a chapter that is often overshadowed by more dramatic stories. The strategic bombing campaign, the development of long-range escort fighters, the introduction of jet aircraft. But for the soldiers on the ground, for the German forces trying to move and fight and survive under Allied air supremacy, the Thunderbolt was perhaps the most immediately dangerous threat they faced. It was the aircraft that destroyed their tanks, that burned their supply trucks, that made movement suicidal, that transformed the battlefield into a killing ground, where the only safe place was underground or under heavy cover. The 850 caliber machine guns, the 10 5-inch rockets, the 2,500 pounds of bombs, these were not just numbers or specifications. They were instruments of a kind of warfare that industrial powers wage with particular effectiveness, where technological capability and production capacity combined to create overwhelming tactical advantages. The P-47 was a weapon of abundance, a machine that could only exist in a military system with deep industrial reserves, extensive training infrastructure, reliable logistics, and the organizational capacity to learn and adapt continuously. The Germans had faced superior numbers before. They had developed tactics and weapons to fight outnumbered. But the P-47 represented something more than simple numerical superiority. It represented systemic superiority. Superiority in production, in organization, in the ability to identify problems and implement solutions, in the capacity to sustain operations despite losses, in the industrial depth that made every loss replaceable and every success repeatable. Years after the war, aviation historians would analyze the P-47's technical,